And with that, I will now hand it over to Natalie Surwicki, who will introduce our presenters. Natalie, you have the floor.
Thank you, Aurora, and hello, everyone. My name is Natalie Surwicki. I'm a marketing manager at Amazon Web Services, and I want to thank you for joining us today at our webinar about scaling on AWS for your first 10 million users. I'd like to introduce you to today's webinar presenter. Chris Munns is a solutions architect at Amazon Web Services and is based in New York City. He spends a lot of his time working with AWS startup customers, helping them architect solutions being deployed in the AWS cloud across a broad range of technical scenarios. And prior to joining AWS, Chris had spent a number of years gaining cloud operations and architecture experience, including holding senior operations engineering posts at Etsy and Meetup. And with that, I'll hand it over to you, Chris.
Thanks, everybody. So I guess we'll get started here. Thanks again also for everyone joining, and thank you, Natalie, for the introduction. So we've kind of already gone through the overview here. Again, my name is Chris Munns, and I am a solutions architect at Amazon Web Services. And hopefully all of you are here today to learn more about scaling your infrastructure on AWS. And today is a lot about best practices and things to think about when building for a large scale. A lot of these are examples. They're not the only way that things can be done, but these are definitely kind of a collection of the best practices and the things that we advise for. So how do we scale in AWS, right? It's a big question. Depending on what you're looking to do and what your goals are in your organization, it could be quite a complicated problem. And generally, a lot of people now that are building on cloud are doing it for the first time or early on. And there's not a lot of experience given that this is kind of new technology in a new realm. So a lot of us start off at kind of a common ground trying to figure out what we're doing and what we're looking to do in building our infrastructure on AWS. And a lot of us start out with the most basic of knowledge on it or very little understanding. So if we were going to build something large in AWS, where would you start? Well, with a lot of things that I'm looking up to try to figure out, my first turn is to a search engine to look for it. And if we were to go and open up your favorite search engine and search for scaling on AWS, you would probably see these first two entries come back as your results. And I'm here to tell you today that these are not actually the places that you want to start. You'll notice that there are actually a lot of things for you to read here, almost 1 million results that come back when you search for scaling on AWS. And the first two about auto-scaling actually, though, are not actually the panacea that we're looking for here to get us going. So while auto-scaling is a tool and a destination, it's not the single thing that fixes everything for us. There's a lot of things that we need to put in place before we could do that. So what are some of the things that we need first? Well, in the most general sense, we need some basics. So when talking about Amazon Web Services, we have a couple of different concepts that make up the infrastructure and the services that we have. At the topmost level, we have regions. Regions are disparate geographic areas where we have collections of data centers and most of our infrastructure. So we have 9 of these today, including our government cloud region located in the U.S. The rest are located around the world. We have 3 in the United States, 1 in South America, 1 in Ireland, 1 in Tokyo, 1 in Singapore, and 1 in Sydney. And then these regions are comprised of many availability zones. So an availability zone you can think of as separate plots of land that have 1 or more data centers on side of them, and those different data centers would make up an availability zone. Now, availability zones are wholly separate from each other, different power grids, different floodplains, different fault lines where applicable, and different Tier 1 network connections between them, with the idea being that you want to build your infrastructure across multiple availability zones for the highest level of resiliency. So we spent a lot of time talking about multi-AZ, and it's a very important component when you're building on Amazon Web Services. To give you a little bit of an idea about the scale of Amazon Web Services, we can look at our friends in the retail side of Amazon back in 2003 when they were a $5.2 billion retail business, a little shy of 8,000 employees, and a whole lot of servers. Right now at AWS today, we add enough server capacity to power that entire $5 billion enterprise, again, every single day. So constantly moving, constantly scaling, constantly growing to be able to handle any sort of application that you might want to run on top of AWS. So from an infrastructure perspective, we should always have enough horsepower for you to have whatever application, whatever business, whatever it is that you need to do computation and storage-wise, capable of running on us. we're to dive a little bit deeper and look into what actually AWS is compromised of, we have a couple of different kind of major blocks that make up our different services. So we have AWS Global Infrastructure, the regions, the availability zones that you saw. We have networking services, compute services, storage services, database services, higher level application services, and then deployment and administration tools. Kind of a quick snapshot of how you would view those. Again, we have over 30 different services. These are the 25 different categories that we have directly in the console that you could use and access today. So just a kind of a quick snapshot of the different services and what's available to you on AWS. So now that we kind of have some of that foundation down, let's take a look at what your infrastructure might be starting from day one, user one. Basically you setting up, the initial component of your infrastructure. If we were to look at that in the most simplest sense, this is what it could look like. So we have a single EC2 instance that we would run potentially our full stack on. In this example, let's assume that it's a pretty standard, 3-tier web application. We've got a front end, and we've got an application server, and we've got a database, and there's some management involved there. We have a single elastic IP address. This is what gives you a static IP address on top of an EC2 instance. And then we're using Route 53 for DNS. So our users would come in. They would look up your website, example.com, and that DNS query would get returned to you by Route 53, and then that would push you to the elastic IP that would serve up your site. And so while this is a great place to start, obviously you only have a single instance. So in terms of instances and scaling on top of a single instance, this is definitely the simplest approach that you could have. So we have a lot of different instance types, ones that support high I/O, high memory, high CPU, high storage, and now you can make leverage of EBS services like provisioned IOPS. And this could actually get you really, really far. The problem is at some point you will hit an endpoint. There will be a point when you've scaled up to the largest size of an instance that we have. And so vertical scaling is definitely not going to take you all the way. So if we were to look at what you would do beyond vertical scaling, other problems with this obviously is that there's no failover, there's no redundancy, and we have too many eggs in one basket here. So if we were to look at what the next step beyond this might look like, we need to think about how we'd solve those problems. So the next most simplest thing to do is to separate out our application into multiple tiers. So here we see an example of how we've split up our database tier from our web and application tier into another instance. And maybe you want to make use of a database service, right? If you're starting out fresh, maybe you're part of a small team or a small organization, it may not make the most sense for you to have to manage all of these different components yourself initially. So at AWS, we actually have a number of different database options to help you out with that. Obviously, as I said, you can definitely manage this yourself and run it on EC2. Nearly any database that you could think of, you can run on EC2 yourself, from Oracle to Microsoft SQL to MySQL to different open source solutions such as Cassandra or Mongo. But what we do have are a number of managed options to help you out. So we have Amazon RDS, Relational Database Service. This is a managed offering that supports Microsoft SQL Server, Oracle, or MySQL, has very flexible licensing. You can either bring your own license or have the license included, and offers a lot of neat things to help you scale and help you have redundancy built into the platform. The next option we have is something called Amazon DynamoDB, which is a managed NoSQL database service built on top of SSDs, very, very fast, and meant to have basically zero administration on top of it. When you set up Dynamo, you just say the amount of reads and writes that you would want, and Dynamo takes care of all the magic behind the scenes to make sure that you have a fault-tolerant, partitioned, very high-scale database to serve your application. And then the last option that we launched earlier this year is Amazon Redshift, which is a massively parallel petabyte-scale data warehouse service. Again, like many of our other services, the idea here is to minimize the administration that you have to do while giving you the ability to scale it really far. So Redshift can help you out with that. But now we kind of have a bigger question here, right? We have all these different options here. What is kind of the best place to start? And it's definitely something that's pretty a hot topic these days, picking whether we want to start with a SQL or a NoSQL offering, borders on a religious war in a sense. So with lots of different options at hand, a lot of people ask myself and the other solutions architects at AWS, what technology do we choose? And so some folks don't like this. Again, it's a thing that a lot of people have personal preferences on. But I'm here to say that given the experience of what I see and working with many different customers across many different industry and vertical types, that I recommend starting with SQL databases. And right now there's a lot of people who are probably feeling a little squirmy about that, and you've got lots of reasons why SQL databases won't work for you, and you feel that you're going to break a SQL database, but the reasons that you have are probably not as true as you think. And what we see is a lot of people misusing NoSQL database solutions these days and not really thinking about how their data interacts with each other. So again, the general recommendation that we have around this is to start with SQL databases. So again, why would you start with SQL databases? These are established and well-worn technologies. In a sense, SQL's been around since the 70s and improved and grown over a very long time. There are lots of existing code, communities, books, background tools, et cetera, that you can use to help gain knowledge and understand on how to scale and use SQL. You're also really not going to break SQL DBs in your first 10 million users. You really won't, unless, of course, you're doing something really super weird with your data or have massive amounts of it. And then again, there are really clear patterns to scalability, lots of other very large organizations that are using SQL technology and building on top of it. So right now there's a lot of people who are saying, aha, you said massive amounts of data, and that's me. I will have massive amounts of data. And I think it's important to kind of quantify what it is when we talk about something like that. So my general rule of thumb is if your usage is such that you think that you're going to have more than 5 terabytes of data in your database, that is, in your first year, or you have an incredibly large amount of data or incredibly data-intensive workload, you might need a NoSQL offering. But again, this is probably less than 90% of you. And so you really want to spend the time to think about how you're accessing your data, how your application accesses your data, how different entities inside of your application will work with each other. A lot of things that people skip past is thinking about that step of how their data interacts with itself and your users, and that can lead to a lot of bad decisions being made early on in defining a project and the technologies you'll use. So going back to our topology here and looking at scaling past our first 100 users here, in this option here, we're going to go with using RDS to help us get past that initial hump of separating out these two different tiers. But then what is the next step beyond this? So the next step beyond this is actually really to take advantage of multi-AZ deployments, as we were talking about earlier. Again, multi-AZ exists in AWS as an ability or kind of an option to help you both scale and be more redundant in your infrastructure. So in this case, what we've done is we've made use of the multi-AZ features in RDS to allow us to have a primary instance and a secondary instance. We've also set up 2 different web instances, one in each AZ, and now we're also leveraging elastic load balancing to spread the traffic between those 2 different web instances. So just with this topology here, you could probably get to several thousands of users here. And so Route 53 will be pointing at our elastic load balancer, which will push the traffic back to our web instances, which will then talk to our primary active RDS instance. And if at any point any component of this infrastructure were to fail, there's actually enough redundancy built into it that it should shift traffic over to the working parts of this. So to go a little bit deeper here on elastic load balancing, this is a service that we have that allows you to create a very highly scalable load balancer for your infrastructure, for different tiers of your infrastructure. We have the ability for you to have externally facing ones and then internally facing ones also inside of VPC. It does health checks back against your instances. It supports session stickiness. It can do SSL offload for you. So instead of doing SSL work on top of your web instances and taking the CPU load there, you can actually push that up to the elastic load balancer and lighten the load on your actual instances yourself. And it has built-in monitoring. You can push a lot of different metrics to CloudWatch, which is a service we have for metrics and monitoring purposes. And so with Elastic Load Balancer, we see customers doing tens of thousands, if not hundreds of thousands of connections through an ELB. And some of the largest sites some of our largest customers using ELB to handle a whole lot of traffic, and you should feel comfortable in using it to scale yourselves. So essentially building on top of this, scaling this horizontally and a little bit vertically again, will get us really far, to the tens of thousands. Again, people I think often underestimate just how much you can do with a simple topology like this. So if we were to look at this a little scaled out a little bit further here, What we have set up, again, is using RDS. We have our multi-AZ instance, the master and the secondary, and then we have a number of read replicas. With RDS and MySQL, we have the ability to set up a number of read replicas that keep in sync with the master, and then we can have our web tier on top of that also scaled out to a number of instances behind an ELB, such that we should be able to handle tens of, not hundreds of thousands of users accessing our web application very rapidly and without us having to do a whole lot of work. So again, this will take us really, really far, and this is actually the topology that we see a lot of our customers end up in for a decent amount of scale. But if we care a lot about performance and efficiency of our application, there's still a lot of things that we can do to clean this up a bit. So the first thing that we can really do that you should definitely look into is to shifting some of the load around. So initially with this topology, we just had a number of web instances that were serving everything from our site. But a really strong thing that you can do with AWS is make use of services such as S3, our simple storage service, and CloudFront, which is our content delivery network, to offload some of the serving of your static content. So this could be your CSS files, your JavaScript, static images, videos, any sort of static data that you might be sending out to your users. And so in this case, what we're going to do is put those files on S3, put in front of that CloudFront and reference that as some sort of a media URL through Amazon Route 53. Another thing that we might want to do here is move some of the session state off of the web instances. Let's say that we were keeping session state there previously. Move that to something like Elasticache, which is a hosted Memcached offering, or to DynamoDB. And you also would probably want to do this to move some of the load off of your databases. So again, lightening up some of the work of these tiers, moving some of this stuff to some other tiers that can scale horizontally for us will really help you get your infrastructure to that next level and help you scale a little bit further. So in working with S3, again, this is one of the original services that AWS launched many, many years ago. It's an object-based storage for the web. So it's not a file system. It's not a block device that you mount to an EC2 instance. This is a service that exists. It's web accessible. You can control very fine-grained the access to it such that you can allow certain objects to be read over the internet, certain ones to be privately held and accessed only via an API and secure credentials. It provides 11 nines of durability, which means that it's an extremely, extremely durable service. And actually, we announced back in April at our New York Summit that Amazon S3 right now holds 2 trillion objects and processes probably a little over 1.1 million requests per second on average. So it's a massively scaled service and something that's very flexible and easy for you to work with. And a lot of our very largest customers make use of S3 for a lot of different things. It ties in really well with CloudFront, such that you can do restricted content from CloudFront back to S3. It ties in with EMR, Elastic MapReduce offering. It can act as a logging endpoint for S3, CloudFront, and for billing. It supports encryption at transit and at rest. And there are a couple different options for slightly lower cost options, such as reduced redundancy mode or Glacier, which is used for super long-term storage. Another service that we talked about just a minute ago in terms of offloading some load from the different tiers of your application that I mentioned a little bit earlier is DynamoDB. Again, this is a provision throughput NoSQL database. It's meant for very fast and predictable performance. The idea here is that there should be very little overhead in you needing to manage Dynamo, and it's a very, very flexible, high-scale service that we have. So it makes sense to use as a place to hold session data. An example that we always like to give is one where we would hold something, say, like cart information for an e-commerce shop, but a very flexible tool, very dynamic in its ability to scale. It's something that has built-in fault tolerance and multi-AZ by its nature. And then the next component that we had introduced here was Elasticache. So Elasticache right now offers up a hosted Memcached compliant offering. So it speaks the exact same API as the traditional open source Memcached, except that what we do is we get rid of you having to worry about managing the nodes that it's on. So you can scale from one to many nodes inside of a cluster. It will heal those nodes if one were to die or to go away. It's very, very fast to use Elasticache. It's considered one of the best caching technologies that's out there available. Usually you get single-digit millisecond speeds off of an Elasticache node back to your instances. They are, however, local to an AZ, so you have to think about running different clusters and different AZs. And also the data is only in memory. So this is not a place where you want to keep super important data, but it does make a lot of sense for things like session data or caching results off of a database. So now that we've been able to kind of lighten up the load of our web tier, we're actually now able to go back to something that we talked about at the beginning of the talk that we mentioned wasn't where we wanted to start, which is auto-scaling. So auto-scaling, a very important component of what you can do on Amazon Web Services, something that's built directly into the platform in Amazon EC2. So with auto-scaling, it's something that you set up such that you're able to do horizontal scaling across your instances. To give you an example of this, take an example of a web application that you wanted to scale up and down with traffic. And so with that, what you were able to do is set up auto-scaling and certain triggers around how you're going to handle that scaling. So let's say that you have a typical kind of traffic pattern where during the day you have a lot of traffic, but then at night you don't. It's very easy to set up either scheduled actions or actions built on top of metrics such as CPU load for a pool or latency load off of an ELB to have that trigger. A scaling action, which would be adding more instances. So with that in place, I wanted to give just kind of a brief example of how you might want to end up using auto-scaling. So if we were to look at this chart here, this is a typical weekly traffic to Amazon.com, just as an example. And we could see here the example that I was giving of during the day, we have a lot of traffic, and then at night, it trickles back down again. If we were to do traditional capacity planning for this, it's actually not too difficult, right? We could say that we're going to cut a line 15% above what we envision our peak traffic to be, and then we could just have a number of running instances for that at all times. And this could work really well if this is what our traffic were always going to look like. But what about if our traffic looked like this? So this is an example of potentially November traffic to Amazon.com. At the end of the month, we have a lot of holiday shopping going on. You can think of the first spike potentially as Black Friday, and the second spike as Cyber Monday. If we were to do the same kind of capacity planning, well, we'd have a whole lot of wasted infrastructure running. Potentially 76% of our infrastructure could be wasted, whereas we'd only be making use of 24% of it if we were going to be provisioning capacity just for the spikes. But if we were to use auto-scaling, we could actually tie this directly down to the load that we have coming into us and have only a certain amount of infrastructure running such to handle that. So again, this is a really powerful component of EC2 that allows you to have this kind of flexibility in how the number of instances that you have running and how they might grow and shrink over time. So putting auto-scaling in place is definitely a strong component of being able to scale up effectively in terms of cost and performance in your infrastructure. So with that in play, though, there's still a number of other improvements that can be made in breaking apart our web app and tier a little bit more. And so that is using SOA, or service-oriented architecture. So in using SOA, the idea that we're going to have here is moving our services into their own tiers and modules. In a sense, we've kind of already done this with moving some of the caching off of our web or application tier or database tier to Elasticache and moving some of our static content servering from our web tier to S3 and CloudFront. But you can go a lot further than that. And using SOA as a methodology is something that Amazon.com and AWS does extensively and offers really great flexibility and greater understanding of each component that you have. So part of that, you want to make sure that you are loosely coupling your services. The looser that they are coupled, the bigger that you're often able to scale them. You want to think about independent components in your infrastructure, individual actions maybe that your users are taking or that the internal infrastructure needs to take, and then design each of them potentially as a black box, something that isn't tightly interacting with something else but maybe uses common interfaces or common APIs between them. And decoupling these interactions is really what's going to help you have a really flexible, scalable infrastructure. So an example we have here is instead of passing messages directly between two controllers, maybe you pass those messages through SQS as a buffer. Loose coupling plus SOA is really the next key in moving forward in scaling your infrastructure. And in the early days of a new application or new infrastructure or new startup, you really want to spend your time focusing on your business and on your application, a little bit less on reinventing the wheel. Some examples of these are using pre-built services or hosted services for things such as email, queuing, transcoding, search, databases, monitoring, metrics, and logging. We actually have a number of services that can help you out with this. Amazon SNS, for example, is our notification service. We have a search service. We have a queue service. Amazon SCS is our email service. Amazon Simple Workflow is a workflow management service. And then Amazon Elastic Transcoder. And so with loose coupling these different tiers of your application and using service-oriented architecture, you gain some of this flexibility in being able to move quickly. And one quick word of caution, again, I deal with a lot of customers in and around the country on reinventing the wheel. If you find yourself writing your own queue or DNS server or database or storage system or monitoring tool, my advice to you is really to take a deep breath and to stop doing those things and wasting a lot of time on doing them. A lot of times people think that they can't find a solution to what they need to do or that open source won't get them there. But generally speaking, you'll probably find that most of the problems that you have or you're coming up against are ones that other people have solved. And so it's definitely a piece of advice from our side that you don't spend a lot of time trying to kind of rebuild those things from scratch, but that you make use, again, of hosted services or existing open source solutions that are out there. So with that, back to SOA here, just kind of a brief example. So imagine that we let our users upload photos. Typically, when you're starting out, this might be something where they upload directly to your web application, and then your web application might be doing some resizing or storing them somewhere, and then serving those back out to each other. What we have here is kind of an example of an architecture that we often see for something like this. So in this case, our user has uploaded their photo. The photo original gets pushed to an S3 bucket for ingest, and then a message gets kicked off to a simple notification service topic that then gets spread out into 3 different queues. And with SNS, you have the ability to set it up to message 3 different queues at once. So in this case, we've set up a queue per different size that we want of our image. And then behind that, we've set up different pools of auto-scaling instances to handle the scaling actions that they want. So let's say that with all these different sizes that we have, the work required to scale them, to resize them at scale could require all sorts of different CPU load and all sorts of different work involved. So with these different tiers, we have the ability here, with these different auto-scaling groups, we can handle each of these different resizes independently and have them resized in their own queue and in their own pool so as to not tie up or affect the other ones. After a scaling action or a resizing action of an instance has happened, we would then put the image into another S3 bucket, depending on what it was. So if it's a resized image, we'll put it into a reduced redundancy mode S3 bucket to serve the content to CloudFront. And we're going to use RRS here because what we could do is, at any point in time, we're keeping the originals in a normal redundancy S3 bucket so that we could always resize it if we ever needed to. And this is a great cost savings tool for you to use with content that you either transcode or resize. And then we'll serve that content back out via CloudFront to the end user. So this is going to, again, get you really, really far, but getting over that 1 million mark is really going to require you to do all of the different things that we've talked about to some degree. So making use of multi-AZ, again, having your infrastructure scaled out across multiple availability zones for redundancy and scalability purpose, making use of services such as Amazon Load Balancer, again, a self-healing, self-scaling tier that can span availability zones and direct traffic between different tiers of your application. Making use of auto-scaling such that you're getting the best cost to performance to traffic ratio that you can out of your infrastructure. Making use of service-oriented architecture to break up the components of your architecture instead of have everything lumped into one application. Serving the content smartly, right? Making use of S3 and CloudFront, making use of reduced redundancy mode where you can to help cut back on costs of things such as resized images or transcoded video files. Move caching off the DB. Again, you want to make the best use of that database tier that you have. And for a lot of things, you'll find that putting a caching tier in front of it can offer you up really a great amount of offload from that database tier to that caching tier and give you even better performance in your application. And then again, moving state off of tiers that auto-scale. Because of auto-scaling, you're going to be growing and shrinking potentially a tier. You have to think about where it is that stateful data lives. You wouldn't want session data to live on an instance that auto-scaling is now terminating. So you want to think about how you'd put that state into something like Elasticache or DynamoDB such that it won't get deleted because of an auto-scaling action. So what does our topology look like now? Well, this is kind of just one view of it here, and we're only showing a single availability zone, but imagine everything that's in this one availability zone doubled up into another availability zone. So we're making use here of our web tier inside of an auto-scaling group, talking to our RDS database tier, which is still making use of a multi-AZ setup, as well as having read replicas. And then we're also using Elasticache to offshoot some of the database caching and maybe some of our session data. We have worker instances for resizing our photos that are talking to Amazon SQS, and then maybe below that we've got some internal application that needs to run, and so we have that in an auto-scaling group. And then we could be making use of other services. Let's say that we need to email our users from time to time as part of our application flow using Amazon SES, which is a very high-scale email sending service. To send those emails could be a lot more effective than running your own email servers in AWS 24/7. Making use of CloudWatch to monitor everything will give you a lot of information on what's going on in your infrastructure and how it's performing. And then again, using S3 to serve up that static content through CloudFront, our CDN service. So that's going to get us pretty far, and it might get us well over the million user mark into the single-digit millions. But what are some of the next big steps that we're going to run up against? So the next thing you'll probably start to run into is really issues around your database and contentions on that right master that we have in this case. So how could you solve it? There's a lot of different options that you have here. The three most common that we see are federation, splitting the database into multiple databases based on function, using sharding, which is splitting one data set across multiple hosts, or moving some of that functionality to other types of DBs, potentially a NoSQL offering or something similar. So in database federation here, the example that we have is that we're moving specific databases off of a single database into multiple tiers that we can then scale independently. And this is often the first stop for a lot of our users in scaling their application, and that can actually get them pretty far over the hump of running into contention issues and making sure that they've purposely separated these things out. And it's going to delay the need to do something like sharding or working with a NoSQL solution until much further down the line, which is why it could be a good first step in moving forward past having a single database or a single data store. The next step that we see happen offering is actually going with a horizontal sharded solution here. And this is where you have a number of users that are spread out across multiple different instances. And then based on that, you have your application understand where that data lives. So in this case, you've got some data that's living on shard A and some that's living on shard B and some that's living on shard C. Obviously, this makes it a little bit difficult to do full joins across the entirety of your data set, but this could still be a very flexible way for you to have all your data stored and scale very easily. You can just keep adding shards. And this is something that's done by a lot of large organizations, Instagram, Pinterest, Tumblr, Flickr, Etsy, to an extent Facebook, and even Google do things around using sharded databases. And this is something that you can do strictly with just SQL-based databases, or you could be doing something like this with a NoSQL-based solution. The other thing that you're going to run into once you get into the multi-million user mark here is that you'll start to see that the speed and performance of your applications, those different services that you have in your architecture, are going to start to be something that you want to focus a lot more time on. So you really want to make sure that you have proper monitoring and metrics and logging in place. And again, if you can't build it internally, you should definitely outsource it. There are a lot of third-party solutions that can help you out with any of these different things here and help you get past the initial scale and initial bottlenecks that you have. So when starting out small, I definitely recommend looking at some of the third-party providers that we have. Also pay attention to what your customers say work well. If customers are complaining that your forums are slow, that's something that you should look into. If customers are saying that the checkout process is slow, that's something that you should try to look into. And you really want to try to work on squeezing as much performance out of each service and component as you can in a reasonable sense. So you want to look at the metrics for these different things, look at the logging that goes into place, and pay attention to each of those. Brief example here of the different kind of metrics that you really want to be thinking about. host level metrics, again, the individual instances that are inside of your infrastructure and how they're performing. It's a good idea to keep on top of these. Beyond that, though, you want to pay attention to the aggregate of those. So if you have a web tier that is using auto-scaling, looking at individual instances is probably less important to you than looking at how the entire pool is doing. So pay attention to those aggregate level metrics as well. Using log analysis, a lot of different tools to help you out with that. And then lastly, don't forget that you should be checking your site externally. So you should look for an external monitor that can go and do even basic ping checks, because monitoring just internally doesn't give you the full picture of what your users are experiencing. And I often like to say that not having proper monitoring metrics in place is like flying a plane with an eye mask on in a thunderstorm. Oh, and the co-pilot just told you that your wing is on fire. Without having these tools in place, you really don't know what's going on in your infrastructure. Without having effective tooling, someone saying that, oh, the site is slow today doesn't mean anything unless you could turn around and say, oh, you know what, the metrics do say that the site is slow. We should probably investigate what might have changed or what might be broken. Again, in this place, we have a lot of different options for you to help you out with some of these tools. You could check the AWS Marketplace and the AWS Partner site to find out some of these options. With a lot of them, the pricing is aligned well with EC2 usage model, so pay by the hour type of a thing, very flexible licenses. Some of these you can launch just in minutes and begin using them. And again, there are several hundred products across 20-plus categories, more and more every day. So make sure that you spend the time needed to look at these kind of tools and build this into your infrastructure. Another thing that you'll start having to think about a lot more once you get up to this kind of scale is actually managing your infrastructure to handle the ability to deploy your applications, to make changes across your infrastructure, to see what's going on with it. And so there are tools that you can use to manage AWS resources, and then there are tools that you can use to manage the software and configuration on your instances. And obviously, you want to make sure that you have data analysis and logs of user actions. So an example of some of the tools that we provide you here in terms of managing your infrastructure on AWS are Elastic Beanstalk, OpsWorks, CloudFormation, and then, of course, at the very end, doing it yourself on EC2. Now, with Elastic Beanstalk, this is essentially our platform as a service offering. The idea here is that you deploy code out to Elastic Beanstalk, and it builds a highly available, highly scalable architecture for you without a lot of work. So it's something that gives you the most amount of convenience, but probably a little bit less control than some of the others. OpsWorks is a service that we launched earlier this year. It essentially allows you to deploy layers of your infrastructure, individual tiers essentially, using Chef and some other tools to help you scale up and scale down. And it gives you a bit more control, but it requires you to do a little bit more work. More on the do-it-yourself side is CloudFormation, which is the template-driven system to deploying your infrastructure. With CloudFormation, you can list all the different resources and many different parameters that you have for your infrastructure, and CloudFormation will intelligently build and stand up that infrastructure for you. And then, of course, lastly, you could do all this manually on EC2, but when you're at the scale where you're trying to serve millions of customers and millions of your users, it's probably not going to work out too well for you, so you want to look at leveraging some of these tools to help you out with that. Beyond the AWS layer, you want to look at using some other tools to actually do host-based configuration for you. So two of the tools that we often see used by our customers are OpsCode Chef and then Puppet Labs' Puppet. They both more or less do the same thing at this point in time, and there's not a huge change between them, huge difference between them, slightly different syntax, but more or less I think that they are both pretty much on the same footing these days. And you're going to want to use one of these tools alongside one of the previous tools, and often they integrate really well together. Again, OpsWorks already does use Chef built in, so that might be a good place for some people to start. If you want to spend the time required to learn how these tools work, once you have these tools really figured out, you'll find that you'll be able to very easily push out changes, push out application code, push out security patches or security fixes to your infrastructure very, very rapidly and very efficiently, and that's definitely something that's very important for you to do, especially while you're dealing at scale. So a quick review here of what we've covered so far today. Making use of all the different things that we've talked about is really what's going to help you get up to 10 million users. Again, using multi-AZ across your infrastructure, making sure that you have that redundancy and you have the ability to scale in different AZs is really kind of a bedrock component of building your applications and your infrastructure on AWS. You want to try to, wherever possible, make use of self-scaling services, Elastic Load Balancer, S3, SNS and SQS, Simple Workflow, SES, etc. You want to try to build in redundancy at every level. Think about all the different components you have and look for any sort of single points of failure that you might have and get rid of them. Again, I really do recommend that you start with SQL. I think it's probably the best place to start to give you the best foundation for the beginnings of a new application or a new infrastructure. Move to NoSQL if it really makes sense. Again, really spend the time to look at how your data is being accessed. Look at how you plan on having your data be interfaced between multiple records and multiple users and so forth, such that you are really using the right database technology for that. Try to leverage wherever possible managed and low-touch services. Again, things like DynamoDB, where you just set the read and write operations that you need and it takes care of everything else for you, can be really beneficial and something that you will give you more time to focus on what's really important to your business. Look at splitting your tiers into individual services. Again, service-oriented architecture is a term that's been around for probably at least 10 plus years nowadays, but I still see a lot of organizations that don't think about it till too late. So think about the different flows inside of your application. Think about how you have different components of your application and your infrastructure that interface with each other, and think about how you can best separate those out to enable you to better scale and grow those different services. Use auto-scaling once you're ready to. Don't jump into it right away until you've been able to do some of the above things, because you'll find that you won't be able to efficiently use it really well. But once you have taken care of some of the above, you can definitely use auto-scaling to help you keep on top of your cost as well as keep on top of your performance and your ability to serve back to your users and your customers. Use automation tools wherever you can in your infrastructure. Again, look at things like Chef and Puppet. Look at some of the tools that we have like Elastic Beanstalk, OpsWorks, and CloudFormation. If you're not using these kind of tools, you're going to find that you'll have to do a lot more legwork to get your infrastructure and your applications up and running than you would otherwise. Make sure, again, that you have really good metrics monitoring and logging tools in place. This is the foundation of a strong infrastructure and the thing that really differentiates companies that have a strong understanding of their infrastructure and are able to handle issues well versus those who don't. So spend the time up front to invest in these tools, both in the time and the money sense. Again, look at outsourcing them where possible. These are solved solutions for a lot of different reasons, and so you shouldn't be afraid to use third parties for this. And then lastly, don't reinvent the wheel. A really important thing, I spend a lot of time with startups and other companies where someone has a crazy idea that they need to write their own DNS server or their own storage system or something similar. If it's not really key to your business and to your application, you should really be asking yourself if there's better places for you to spend your time on. So putting all of these things together and everything that we've talked about today will definitely get you to your first 10 million users, if not a little bit beyond that. Again, you really want to focus on all the different components of your infrastructure. Think about how you can make them highly available. Think about how you can make them as light of a possible service so that you can individually break them up and scale them. Think about automation. Think about the metrics monitoring and logging component. So in scaling above 10 million users here, and this is kind of the little added bonus onto our slides here today, again, a lot of what we've covered is really going to keep getting you further and further and further. And iterating on top of these and perfecting all the little components of your architecture is what will get you to potentially 100 million users and above. Above 10 million users, most of what we see happen that people need to focus on is obviously continued fine-tuning of your application. This is where it really helps to make use of a tool that can do deep profiling of your application to see how different components are interfacing with each other. We have a lot of partners in this space that do a really wonderful job of it. More service-oriented architecture, so breaking up your application even further into individual features and functionality. Again, Amazon.com and AWS make use of hundreds of internal services to power what we provide our customers. You might have to start looking at going from multi-AZ to multi-region. Again, this is not something that I usually recommend early on, going multi-region. You'll find that you can, with multi-AZ, be able to handle proper fault tolerance, proper disaster recovery, and so I do really recommend that initially you start off focusing much more on multi-AZ than you do multi-region. You also maybe at this point need to start thinking actually about building those custom solutions. So while it's not worthwhile for you to do this in the smaller, younger size of your application, you might find that you do need to actually write a custom queuing service or something similar that is very fine-tuned to your application, but you really won't understand how to quantify that until you're at the point where some of the other solutions that are out there just aren't working for you well. And again, and this kind of goes through everything else, really deep analysis of your whole stack. So this is where metrics and monitoring and logging really come in handy, deep profiling of your application tier, and really trying to understand all of your components. So in terms of next steps here, obviously there's a lot of reading that you could do. We have a lot of public-facing documentation. Nothing that I covered here today is anything that's top secret or hidden from you. If you go to aws.amazon.com/documentation, you will find a ton of material to help you understand all of our different services and a lot of our best practices. aws.amazon.com/architecture has some of our most common architecture patterns, including some of the ones that we covered today and how we see customers building and working with those. aws.amazon.com/startups is a great place to read about what other startups are building on top of AWS and what they've experienced and what's worked out best for them. So I definitely recommend you to investigate those different sections of our website. The next thing is to start using it, start playing with AWS. We have a free tier that covers almost all of our services and gives you a certain amount of free usage for up to a year for first accounts. This is a great place to get started if you're just trying to understand AWS and build on top of it. So go in there, play, launch things, see how they could be configured, see how they could be changed, and again, you could do all this mostly for free. And then lastly, ask for help. We have a very robust community in our forums, forums at aws.amazon.com, where there are dozens, if not hundreds of posts each day. Members of our support and service staff are usually there helping answer questions as well. But beyond that, there's a lot of other experienced people, peers of yours, that might be able to help you out on the forums. You can also work with our support organization. We have a full 24/7 support organization that's available to you, different tiers of our support that we have. So I definitely encourage you to look at support, to be there to help you out when you're stuck or when something's not working quite well for you. And then lastly, reach out to your local account manager. So reach out to somebody at AWS that can help you out. And there's ways that you can contact those people off of the main aws.amazon.com page. So with that, I want to thank you all for listening to me here today. Hopefully you've had some good takeaways and some things to think about. And now we're going to turn it over to try to do some quick Q&A here based on the questions that you've asked. Again, if you look down at the bottom of the screen, you should see the Q&A button. So feel free to send us some of those questions.
And Chris, while you're looking through there, I do want to remind everybody that the recording will be posted to YouTube, and I will go ahead and edit that, get the audio glitch out of there, so it should be a seamless recording on your end if you feel like you missed any information. And that'll be up within 24 hours, and like I mentioned prior, you'll also receive an email with the link to that. And also in your Q&A pane there, I put in the link to the SlideShare channel and also to our YouTube channel. So if you want to go ahead and bookmark those, then you can always have access to our on-demand content as soon as it gets up there. And one last reminder to fill out that survey and let us know what you think of today's webcast. With that, Chris, I'll hand it back to you.
Sure. So looking at the questions here, and while you guys are hammering us here with questions, which is great, a couple that came in here were around multi-region. So there was a question, someone said, you recommend holding off on multi-region. What about scaling for global performance? With multi-region, what are some good solutions for syncing databases across regions? So it is true that depending on what your application is and how you're interfacing with your customers, it may definitely make sense for you to look at multi-region. Let's say that you're running an ad platform or something where you had to be extremely low latency back to a database, then you might want to look at multi-region. I feel like that's something that you want to think about investigating maybe after you've really established good patterns and a strong infrastructure. So after you've really understood how your application works, how your application should scale, that's when I think it makes sense to move on more to multi-region than doing it up front. I think if you do it up front, you end up having a lot of overhead in managing these different separated out infrastructures. And so, it's something, again, that might be a little bit too much work up front versus something that once you're a bit more established, you start worrying a little bit more about the performance that you would get off of being multi-region. And thank you very much for that question. So another question, let me see here, was around federation and sharding. So question kind of loosely worded here says federation, sharding, NoSQL, et cetera, but what about data integrity and transaction? So yeah, this is something very important that you want to think about. A lot of NoSQL offerings today don't necessarily offer up any sort of transaction support. So you do have to think about that, and it is one of the things that you do trade off sometimes with some NoSQL offerings. In terms of federation and sharding, if you're still using SQL databases under the hood for that, you still will have a lot of the data integrity controls, a lot of the transaction controls that you need. It's just that your data isn't going to be holed up in a single database table on a single host. So in this case, as you grow, federation and sharding still does make a lot of sense for you, and you can still do that with SQL databases having the kind of integrity concerns that you might have. So someone else here asked real quick, what is your measure of a user, concurrent users, et cetera? And the goal for this presentation, I wasn't necessarily talking about concurrent users, but more kind of in aligning with what a lot of startups build as a metric of importance to them, which is maybe the first 10 million users or 10 million active users per month or something similar. Handling 10 million concurrent users definitely is something that would require a pretty massive amount of infrastructure, and definitely would require building on top of a lot of things that we said. But the goal here was more around kind of the concept of maybe users per month or total registered users that you might have. So someone asked a question here about how would you get your application to efficiently use RDS read replicas, as there's no load balancer for RDS in a sense. So there are a lot of people who put things like HA proxy in front of read replicas, and you can definitely do that. The other thing that you could do is build into your application this concept of read databases versus write databases, and that's something that I do see a lot of customers doing. Obviously, it is a lot of, not a lot, but it is a little bit more work for you to do in the application side, but it's something that's not necessarily too complicated. Someone asked the question here of my application is new and it uses 4 EC2 instances. I know there is a 20 instance limits by default. If more than 20 instances are needed, are most requested for 20 instances accepted by Amazon. So generally speaking, so if you need more than, actually let me back up a little bit. So there are a number of soft limits that are in place across a new account at AWS, and this is for a lot of different reasons that are, protection for our infrastructure and also protection for your credit card. You can definitely put in requests for more instances and other limits to be increased as needed. And generally speaking, as long as those requests are, reasonable in matching patterns that you say you need, it's not a problem. Most often what happens is this is one way that you get in touch with somebody from either our support or our account organizations, and they can help you work through what your use case is. And this is often also the quickest way to get in touch with a solutions architect. But you shouldn't have much of a problem if you're requesting more than 20 instances. It should be very straightforward, and I believe there's I can't remember the exact number, but it's usually within just a couple of business days that they can make that happen for you. Looking for other questions here. So there was a question here. Oh, nope, I already answered that one about load balancing between the web and the database instances. Again, this is something you'd have to do manually, potentially with some sort of a load balancer, HA proxy, or something similar. But beyond that, building that into your application is what you probably have to do. Someone said, how do I know about the companies that are using sharding? A lot of them are very public about their database technologies. You can actually read about case studies that Instagram and Pinterest have with using these. Tumblr was always very public about what they do. Same with Facebook and Google and Etsy and some of the rest of those. So I'm just kind of referencing public things that I've read out there before. Someone asked the question of, does autoscaling have any lag associated with it? So with autoscaling, when you have a trigger to cause a scaling action, such as a scale up, essentially that trigger is something that you define. So maybe you say if CPU load has been above 80% for 15 minutes, increase the number of instances in this pool by 2. At that point, the only lag that would happen after that point is how long it takes for that instance to bootstrap. So right away, EC2 will go and try to launch that instance based on the AMI that you've referenced, and then all that you're really waiting for is whatever work is associated with that AMI that you have set up. So you largely get to basically kind of be in control of your own destiny there. But there's nothing really inherent otherwise that would give lag into your solution. Someone asked, can ELB support SAN and UCC certificates? Yes, it can, and I believe there's documentation or a lot of other forum posts about that. Someone had mentioned a recommendation here around auto-scaling where you aggressively scale up and then conservatively scale down when you start. I definitely agree with that. Something that you definitely want to be thinking about is how quickly you go up versus how quickly you go down. Scaling up more quickly initially can help you get through potentially new bursts of traffic, whereas you might want to be more conservative with how quickly you reshrink that infrastructure such that you don't end up in a point where you don't have enough infrastructure that might be available for you. Trying to go through a lot of questions. A lot of people are asking about features and things like that. Unfortunately, I can't talk about anything like that here today. Definitely my recommendation, though, is to go into the forums and post that you're looking for features or that you're looking for services. Again, we do a lot of our releases and a lot of iterative work on our services based on what customers ask for. So unfortunately, one more question here because we are at the top of the hour. So let's see here. One question that we have here is what factors should be considered when deciding to use fewer large instances versus more small instances? And this is a really great question that we spend a lot of time on. Generally speaking, it depends on the workload. And it also really depends on what the performance characteristics are of your application. Very rarely is an application linearly scaling with CPU and memory increases. Often you'll find that your application uses much more CPU or much more memory or much more network or disk I/O. And so you really want to try to look at right-sizing your instance for that best performance. And then on top of that, when you're thinking about whether you want to have, in some tiers where we have, say, our high memory instances, maybe it makes more sense to have more M2 2XLs and M2 4XLs. You want to think about how, in terms of auto-scaling, how your application would grow, how your traffic patterns grow, and how finite you feel making your scaling actions, basically how granular you might want them to be. So those are kind of things that you might want to think about. And again, really spend the time to look at your metrics and monitoring to make sure that you're using those resources as best as possible. With that, we are at the top of the hour, and so I'm getting the note here that we have to stop with the questions for today. Really encourage you guys to hop into the forums if you want to keep some of this going and ask people those kind of questions there. And want to thank everybody again for your time and coming to join us here today. And the slides will be put up on SlideShare, and at some point this video will be posted as well. Thanks again, and have a great day.